Welcome everyone again. Thank you so much for your time. My name is Sarah Jane, as Camilo said at the very beginning, but this next 2 hours or hour and a half is going to be intense but really good, and it's going to really benefit you. So for the first half, we'll be going through different types of contents like what is blockchain, a little bit into the Algorand blockchain and the origins of it, and how we're doing today by the numbers. Then we'll go into the art of the technology itself. So what makes Algorand different, why the tech is so elegant, and the special features that we have that will help you in the hackathon that you can use to your own advantage. After this, we'll be looking through our different developer experience, which is pretty good. And then we'll go into the real world applications as sort of like an inspiration to show that if these people have done it at such great lengths, you can do any idea you have as well. And then we'll start live coding together because this is a technical workshop. After that, we'll have a small overview, or should I say big, since our ecosystem is growing at a rapid rate. But we'll do a robust ecosystem overview, and finally accelerated adoption. So a little bit about how we're trying to help as the foundation and what to expect in workshop 2. So without further ado, let's get into it. So firstly, what is blockchain? Blockchain is also known as distributed ledger technology. You might have heard that term. And it has a few main factors. So the first one is decentralization. A blockchain is a network of nodes around the world working together to reach a consensus. It is trustless, so the information or data on the network is accessible and verifiable, which just means it's correct. It's immutable, so information cannot be changed or interfered with, and the history can never change. Simply, if you would think of a blockchain, it is a database that can only append data. And not to go too deep into what exactly is a blockchain, but to look at a little bit of how the transactions work, as this will be interesting for later when we're creating our own. So transactions are a standardized data structure, and they want to describe a change into the ledger. For example, updating. Each transaction has one sender. And so for the signing of these transactions, every account in the blockchain is identified by an address, and each address corresponds to a public key. So think of this like your mailbox outside, and each address also has a private key, which is like a key that you shouldn't give to everyone, of course, and that is what signs the transactions. So once you submit this transaction, it goes to one or more nodes in a network, and they validate that transaction, and then the transaction is added to a block. Hence the term blockchain. So, what is Algorand, and what is its origins and key differentiators? If I was to sum up Algorand in one sentence, it would be Algorand is an energy-efficient, quantum-secure, single-layer blockchain with instant finality, consistently high throughput, and low fees. And fun fact, it's been operating at 100% uptime for 5 years, which is really important if you're trying to build applications that affect the real world, for example. So Algorand's origins, how did this all start? So if we go back to the roots, the founder Silvio Micali, who is an Italian computer scientist and former MIT professor, he's also known as one of the modern forefathers of cryptography, thanks to his work such as co-inventing probabilistic encryption, zero-knowledge proofs, which are really popular, and verifiably random functions. And of course, Algorand, which was founded in 2017, but the first Genesis block was in June of 2019. For anyone particularly interested, perhaps in blockchain security and cryptography, a zero-knowledge proof just allows verification of information without revealing the actual information. A bit of a tongue twister. And then verifiably random functions, as this is important for the consensus of Algorand, but we won't go too deeply into that. But it's important to know the infrastructure you're building on. But a VRF generates a publicly verifiable random output, which is essential for secure and fair randomness in cryptographic applications. So how are we different? The number one question people ask is, what makes Algorand different from other blockchains like Ethereum? And maybe you haven't heard of any other blockchains, which is great, because if you haven't, you started at a top-notch position. But if you have, how are we different? So we are ready for global adoption. Algorand's elegant consensus mechanism enables scalability, handling over 10,000 transactions per second. But even at the moment, if we take a look at Visa, they can do, or they're running around 7,000 transactions per second. So there's a lot of overhead that that we don't need to make as important as other things at the moment, because right now nobody is really doing 10,000 transactions per second. But I'm sure as time goes on and more people getting to the financial systems, it will grow. So our blockchain is trustlessly truthful. With instant finality and a block time under 3 seconds, you can be sure that your completed transactions stand as a unchangeable truth. And instant finality means that once the transactions are processed, they are added to the network instantly. We were also designed to endure. So we have an ongoing drive towards true decentralization, which will make Algorand one of the most resilient and reliable blockchain platforms in the world. And lastly, we are leading on post-quantum, which, as time is going on, it's getting more and more important to take a look at how these supercomputers are coming. But on Algorand, we have a quantum-safe state proof, which utilizes Falcon signatures. Once again, for the cryptography heads, it is a lattice-based signature. But every 256 blocks and around 12 minutes, state proofs ensure that the entire history of the ledger is secure against potential threats. So what you should take away from this is when you build your applications on Algorand, you also have any transactions that happen, they are quantum safe. So we really shouldn't fear new technology. So at the foundation, we're preparing now for quantum computers instead of waiting for the problem to come and fixing it then. So if we take a little look at the numbers that we're doing today, as mentioned before, we have a theoretical transactions per second of 10,000, a second block time less than 3 seconds. I think to be exact, it's like 2.8. And each transaction has a set algo fee, 0.001, and that is like a tenth of a US penny, a fraction of a penny. Instant finality, as mentioned before, but it's a really important one. It's very important for payment systems. But once the block time is processed, the entire process is finished. It's very unique about Algorand, and it's a need for consumer adoption. Algorand is mathematically near impossible to fork, and I'll explain exactly what that means in a few moments. But another really cool figure there is we also have 0 downtime since inception. And as of, I believe it was June 2024, but I think I updated it. But we have over 40 million blocks, and we also have over 2.3 billion transactions completed, as well as over 800,000 monthly active users. So now if we take a look at the art of the tech and how all of this is made possible. So Algorand is really technology you can trust. As we went through earlier, lightning fast speeds, never wait for a confirmation. Transactions are instantly final. The block time is under 3 seconds. There's no transaction manipulation, no forking, no rollbacks, and no nonce management means simpler building, easier maintenance, and lower go-to-market costs. So a fork is basically when a blockchain splits into 2 competing paths, and in the end, one of the paths gets deleted, including all of the transactions that were on it. But we really have to keep authenticity and rarity where it needs to be. And an example I use is that there can be no 2 Mona Lisas due to forking. And a rollback is when a series of confirmed transactions get reversed as if they didn't happen. And that is just not very decentralized. And as mentioned before, we are 1/3 of the way to pure quantum secure, with more research down the road in quantum secure VRF and transaction signature scheme. But this is a cool one. We're energy efficient as always, so powering the entire, which is the equivalent of charging a Tesla car. So now, I really like this part. So everything you need in a layer 1. So we have Algorand smart contracts. Of course, Algorand is a programmable layer 1. So Algorand makes it easy to tokenize, transfer, and program conditions on any instrument of value. You can create fungible and non-fungible tokens with a single transaction where no smart contract code is required, which we will be doing later, so stay tuned. Or you can program more sophisticated decentralized applications with Algorand smart contracts. Algorand can write these contracts in Python or TypeScript, or you can use one of our 4 SDKs, Python, JavaScript, Golang, or Java, to connect to on-chain assets or applications. We also have our Algorand Standard Assets. And these are basically the tokens that are on-chain. And they're appealing for many reasons. For example, efficiency, scalability, security. They basically inherit all of the pros of the Algorand network. Atomic transfers. Some of you may have seen our ad we did with hot dogs a few weeks or a month ago, or maybe 2 months ago. But atomic transfers are super cool. So what they allow are multiple transactions to be grouped together and executed atomically, which ensures that either all transactions succeed or none of them do. And this is really key to truly trustless transactions. And you don't need a smart contract on Algorand to perform these types of transactions. Hint, we are also doing this later. Lastly, the last 2, on-chain randomness. So as you know, computers are deterministic programs. You give a computer program an input, it gives you an output. You give it the same input again, and it will give you the same output again. This is predictable, so having a source of trusted and secure randomness is necessary for decentralized applications that may rely on randomized processes, such as lotteries, random NFT drops, or games. And Algorand state proofs, not only do they allow for some post-quantum security, but they also enable trustless bridging between different networks like Ethereum. Won't stay too long on this, but it is important to know what you're building on top of. But what is a consensus mechanism? It's one of the most fundamental tasks in blockchain to be able to secure and make a fast creation of the next block in the chain. So the tool to create and validate the next block is in a blockchain is called the consensus mechanism. And many early blockchains used a consensus mechanism called proof of work, like Bitcoin. While that was useful at the time to prove out the concept of blockchain, it has been shown to be very slow and expensive and energy inefficient. And there has been others like proof of stake again, but Algorand takes the next step forward and uses an innovative consensus mechanism called pure proof of stake, which writes the next block in the Algorand chain. So it takes 3 steps. There's number 1, the propose phase, where one account is chosen to propose the block. Second, the soft vote phase, where a committee is chosen to soft vote on the proposal. And the last phase, the certify phase, where a new committee is chosen to vote on certifying the block. Without getting too complicated and into it, each block has a new proposer and new committees chosen at random using the power of BRF, which Silvio Macaulay invented. And this leads to player replaceability, which is a powerful tool that enhances security. And anybody who has a token can participate. There's no static target to attack, no heavy computation or debilitating energy consumption in VRF, as it is known as a simple task. And this entire process takes less than 3 seconds. Now, if we were to compare the Algorand virtual machine and the Ethereum virtual machine, because the EVM is the most popular or technically the second most popular blockchain out there by market cap. So while transactions per second measures how many transactions a blockchain can process per second, time to finality measures the time it takes for a transaction to become irreversible. So as we can see, Ethereum can handle only 56 transactions per second, which makes it harder to scale, 12-second block times, and 12 to 16 minutes for finality. So if you compare, it's quite a jump into a modern day blockchain like Algorand. And if we talk about programmability, Ethereum has Solidity, which is it's getting a more popular language, but it means you need to learn a new language to build on-chain rather than use a traditional language you would learn in high school or college. There is also Viper on Ethereum, but Viper is not a native Python, but a distinct programming language inspired by Python for writing Ethereum smart contracts. Whereas Algorand now allows you to use native Python, which you can use to write and execute smart contracts. Algorand is the only blockchain that currently allows native Python to build on-chain. And we also have TealScript, which is TypeScript getting ready for production level applications. But there's one thing I always like to point out between this, especially if you guys are hackers or you're building a startup. But if your project needs to do 100,000 transactions, whether it's in a month or a week or even a day, on Ethereum with the current cost of transaction, which I Googled earlier, I think it's $1.07. So we'll just say $1 and be nice, but it would cost you $100,000. On Algorand, if you were to do the 100,000 transactions, it would cost, and any guesses in the chat, feel free to guess, it would cost $15. So now let's get on to the best developer experience in blockchain. It's all about developers, and developers. So with AlgoKit tooling that was launched in March 2023, and since then AlgoKit 2 has come around, it is now possible for any type of developer to contribute to projects on-chain, whether that's backend with Python or front-end with whatever you are comfortable with, as it's an agnostic framework. We also have a very inclusive development environment. It takes just 5 minutes to set up your Algorand developer environment from scratch. And as you know, Python is one of the most popular programming languages with over, I believe, 10 million developers worldwide, growing daily. So Algorand now allows you to use Python programming, so you don't need to learn a whole new language like Solidity. And in the future, we have some cool things happening, especially if you see some of the Algorand Foundation members' Twitters, they post about the AlgoKit tooling. So we'll be bringing out a line-by-line debugging, as well as an integration of an additional common programming language by 2025. Just to do a little focus on Python, because it is a huge thing. As you know, it is used to code machine learning and artificial intelligence, and thanks to Algorand, now smart contracts. If we take a little deep dive into our developer toolset, which I'm sure all of you will be getting stuck into with this hackathon, but AlgoKit really changes the blockchain developer's game from the command line, compiler, top class libraries, easy to call smart contracts with client generator, instant access to testnet tokens, and a Visual Studio Code Algorand virtual machine debugger. We have also just released LoRa. It is basically a blockchain explorer before your transactions, so you can see exactly what is happening when you're building, which we will use later too. And just to focus in on one with the AlgoKit Utils, this is a library to elevate your workflow, and so that you can make your development process a lot smoother and efficient. So get support every step of the way. As you know, we're obviously doing this workshop because we have a hackathon. So I'll put into the chat something. This is if you want to have a look at the AlgoKit page, check it out there. We also have our Algorand developers YouTube channel, which I gotta say, it's one of my favorite YouTube channels. So whether you like to learn with 15-minute bite-sized videos or a marathon and build an NFT marketplace, we have it on AlgoDev's YouTube channel. So definitely check it out. As well as with AlgoKit tooling, which we'll see more in focus in workshop 2, but it's as easy as filling in a 20-second form, whether you want to focus on the back end or the front end, or even both. And as you know, we're hosting the hackathon right now. We work with different types of partners. For example, in our previous ones, we worked with AWS, Circle, Unity, and more. And we also have a GitHub repo where you can enter a code space and begin practicing coding on chain, which we will be doing later. So we still have a few more slides to do, but for anyone who is eager or wants to be ready, this is the code space we will be jumping into later. So feel free to fork it, but don't worry, I will be doing everything from the very beginning. So if you are new to developing, that's also okay too. You can wait with me. Perfect. So before we dive into the live coding, I'd just like to share only a few real-world applications building on the Algorand blockchain, and maybe these ideas will inspire or motivate you to build yours. So firstly, Lofty. So the problem with real estate is, there's a high entry cost. Traditional real estate requires a large capital upfront, and there's not a lot of liquidity. So real estate is difficult to sell quickly and access cash. So the solution that Lofty decided to fill in is to enable fractional home ownership by tokenizing real estate, enabling investors across the US to build wealth through property value growth and rental income. And these stats have changed. These are older stats, but they have definitely gone up since then. But I will still make a note of them. So Lofty has tokenized over 148 properties across 11 US states. The platform has approximately 7,000 monthly active users, and there's over $2 million in rental income has been generated for users to date. Maybe you're into aviation rather than real estate, but TravelX is transforming the travel industry with airline inventory tokenization infrastructure. So what they do is they take your airline ticket and they transform it into an NFT. So it's an NFT ticket, which enables ownership and flexibility. So with this transformed NFT ticket, you can buy and resell it on their marketplace or even send it to your family and friends. You may wonder, why would an airline give up this control? But if they use TravelX, they reduce their operational costs for airlines because there's fewer customer service hassles. And they also increase cash flow because tickets are bought further in advance, as they know it's not going to be a headache if they need to get rid of it. And obviously, we're already partnered and working with airlines like Flybondi and Viva Aerobus, with discussions underway with over 60 plus more carriers. Next, on the farming side of things, AgroToken, which is a South American-based company, I believe Argentina, hopefully I'm correct, but AgroToken connects farmers to financial opportunities by tokenizing their grains, creating digital assets backed by real harvest value, which is just so unique. So farmers can trade AgroTokens for essential supplies, leverage them for loans, or access pre-funded credit cards, as they are in partnership with Visa. So what AgroToken aims to do is connect all players in the agricultural value chain, fostering efficiency and financial inclusion for all. More into the regulated digital euro side. So I guess some of the problems that people have limited access to the digital economy, or there's slower, costly transactions. So the solution that Qantas have come up with, which is licensed by the Dutch Central Bank, allows everyone in Europe to participate in the digital economy, even without a traditional bank account. So EURD isn't a cryptocurrency, stablecoin, or CBDC. It is a electric money token, an EMT, which can be used for everyday use. Thanks to Algorand, it has instant and secure transactions, and it's also within MiCA compliancy. I thought this was a cool quote from Gaston Hendricks, the co-founder and CTO. He said, "Algorand met all the requirements for issuing regulated digital euros on a public blockchain. From a capacity perspective, we can issue all the euros currently in circulation on Algorand and process thousands of transactions per second with instant finality." The last company I would like to talk about, which is more impact before we get onto the live coding, is HesaPay. So HesaPay is the first and only interoperable digital payments platform in Afghanistan. transforming the way people send, receive, and manage their money. They noticed that there was a limited access to financial services in Afghanistan, and there was an inefficient paper-based processes. So the traditional methods were more slow, prone to errors, and costly. HezaPay are doing amazing. These figures are also probably way higher than they are currently. But some cool facts, all 400 districts and 34 provinces in Afghanistan have access to HezaPay, and it has processed over 4 million transactions, including 51,000 humanitarian aid cash transfers and 1.3 million electricity bill payments. They're working with a dozen organizations like the World Food Programme. And yeah, I think this is a good inspirational point to go to our coding. So let me put the link in the chat again. Or it's already there, perfect. So get ready to click on that link. I will share the new screen. So when you click on that link in the chat, it will take you to a GitHub repo. Are people finding it okay? Let me know in the chat if you can get onto the repo. So from this, we will be entering code space, but right before that, we're going to fork it. So to fork a repo, all you have to do is click fork, create fork, and just give it a moment. Perfect. And if you can see your own username in the top left, you'll know you have successfully forked this repo. Next, what we're going to do is we're going to jump into the code space, and I'll explain what we'll be doing inside of it in a moment as well. So to jump into the code space, you just click the big green code button and create code space on main. Once you click this, it will take you to a new tab and it will start loading in your code space. Let me know if anyone's having problems. Perfect. Good to see everyone's getting it. And I'll also change my screen to be light, so it may be easier to see.
And Sarah, could you increase your font size, please, so we can see the command you are putting on the terminal?
Yes. Thank you, Camilo. Okay, so when you enter this code space, it'll take a little bit of time to set up. So I will speak about what we are going to be doing. So, well, that was actually quicker than normal. Okay, so in this, maybe it'll be better if so we'll create our new Python file. So we'll just do main.py. And in here, while we are waiting for others, I will just write what we are going to be doing. So we will import from the AlgoKit Utils library. We'll be connecting to the local net. We'll be importing a dispenser. And all of this will make sense once we start doing it, but it's good to know what we're going to do. We're going to create an account, fund that account. Then we're going to create our own Algorand Standard Asset. Then we'll create a receiver account, fund that receiver account, and make a group transaction, an atomic transfer, where we'll have our user account opt into the asset we created. We're going to simulate a payment transaction. So we're going to add a payment transaction from the receiver to the creator. And lastly, the creator is obviously going to transfer that asset to the receiver account. So there is a few commands to set up first. So I will put this into the chat as well. So in the chat, I've sent, if you just copy that and you paste it in your command line like this, it will make sure we have everything that we need. As we were using the AlgoKit Utils beta version, which is really cool that we get to use these tools. And in our Discord, we also have the latest versions there as well, if you wanted to see what exactly is available. So I'll give people a moment to put in that in their command line. Let me know if you have any issues. And to create a file, if you're new to the GitHub Codespaces, to create a file, it's very similar to Visual Studio Code. You just go on top and create new file, enter main.py or whatever you would like to call it, but the .py shows that it is a Python file. Okay, so I'm going to just also, because I know this is recorded as well, so it can be watched back, we'll get straight into the coding. I'll also try to keep an eye on the chat as well, but my colleague Camilo is also there if you have any questions in the question tab or in the chat. Alrighty, so let's get into the coding. So as mentioned before, we're going to first import from the AlgoKit utils library. So to do this, we do from AlgoKit _ utils .beta, as this is the beta version, .algorand _ client. Next, we do import and open up our parentheses. And there's a few things we're going to import, 5 main things. So the first one is our Algorand client. Next is our asset create params, as we will be creating an asset, followed by asset opt-in params. And I'm just going to import exactly what we need now, as it's much easier than going up and down, as I know some people follow the code quite closely. After our opt-in params, we're going to do our asset transfer. Lastly, our pay params. Okay, great, and I might zoom in some more, and we'll move this to the side and move this down so we can just be focused. Okay, perfect. So the first thing we want to do is have our client connect to the local net. To do this, we instantiate Algorand as our Algorand client, which we imported from above, with default _ local net. And I'll write comments on top of these, actually, just in case anyone is wondering what they do. So client to connect to localnet. Great. So the next thing we need to do is obviously to have accounts and to have them be active, they need to have some tokens. So the way to get tokens in your local developer environment is via the dispenser. And it does exactly what it says, it dispenses. So if we have our dispenser equal to algorand.account, as the dispenser is an Algorand account, .dispenser. And we are basically importing this from the KMD, which is a key management daemon. And I like to just print out to see that everything's working all right. Let's test. So this is our dispenser account. I knew I was not spelling dispenser correctly. It looked weird. All right, dispenser. Perfect. Alrighty. So now if we go to our terminal, I will just clear this, and we test out that this is working. We just run our file as if it's any other type of Python file, Python main.py. Okay, so we have a small URL. I think if I just quickly refresh, it will probably work for me. This sometimes can happen due to code spaces.
Because you need to start the local net. Because usually the code space start the local net, but this time is not working as we expect.
Okay, that's probably a great point as well to make. Always try to, before you start coding or if this issue arises, to check AlgoKit localnet status or AlgoKit localnet start. So what this is basically doing is it's creating its own private Algorand blockchain, which we'll be working inside of. I'll also write that command in the
Yeah, for sure.
start.
And okay, we can continue because we have a pretty interesting question from Doc asking, can Algorand be used for transactional apps that are not financial in nature but may have a payment feature? The short answer is definitely, and for example, that is the use case that Travelers is building. They are having the NFT as the element that represent the airline inventory. And regarding the second part of your question, we can ask the DevRel to identify what is the best way to store of chain information, because at the end, this kind of solution are Web 2.5. They are mixing the best between Web 2 and Web 3. But yeah, Algorand for sure can allow you to build this kind of solution.
Perfect. That was a great question. So now if we run the python main.py, thanks to Camilo for reminding me to start the local net, a very easy mistake, we can see our dispenser account right here. And also, what we will be doing later is viewing the transactions we create with LoRa, the Explorer. And if you want to join in and do that as well, all you have to do is make sure you change your AlgoD, your KMD, and your indexer port to public. But we will see that soon. So hopefully everyone is up to this point. If you're having any issues, please let us know in the chat as well. But we'll get straight back into coding since we've just imported our dispenser. So the next thing we want to do is create our first Algorand account. And to do this, we have creator, but you can call this whatever you like. You could call it Bob or My Wallet. But for the point of this account is to create an asset, so it kind of makes sense. So we have creator algorand.account, as this is another Algorand account, but we're going to do .random, so it generates a random one. So each time this Python file is ran, it has its own instantiated creator account each time it runs, which will interact with whatever is in the script as well. So it may look different when in our print statements when we look at it later, but it works for what is on this Python script the minute it is run. Just in case anyone thought it looked a bit weird. So next, let's have a look that we've done this correctly. So we have our creator address. And to view this, we need to put address at the very end of it as well. I also want to show another way to view some more information, not just the address itself, as you may need to view other information for different reasons. But to do that, we do print algorand.account.getInformation, as we're getting information from an account. It's quite readable. And creator.address. If we run this, we see obviously the dispenser account, as we still have that in our print statement, but we have our creator account, and we also have a lot of information. So we can see it has 0 amount of any algos. It's not currently opted into any assets. So let's first of all fund it. And to fund it, we use our dispenser account. So we're going to be creating our first transaction, which is pretty fun. So fund creator account. To do this, we do an algorand.send.payment, as we're sending a payment transaction to the network. We open up our parentheses and we use what we imported from above, pay params, as this is a payment. And we open up these parentheses to fill in a few fields. For example, our sender field, as well as our receiver field. And lastly, the amount, because we need to know what amount we're going to be sending to fund the account. So in the sender, it's going to be the dispenser, as that's currently the account that has all the algos. and make sure you put address so it pinpoints it. Next, we will be doing the receiver account, which is what we just created above. So creator.address. And lastly, the amount. We can just do 10 million microalgos, which is equal to 10 algos, which is more than enough. We already know the transactions only cost 0.001 algo. So this should be good. After this, let's do a small print statement to see it happen. So if I just take the print statement from above and paste it down here, I'm also going to comment out some so our command line doesn't get too messy. So now let's have a look at this first ever payment transaction. And great. So you can see in the first one above, obviously the same creator addresses. But if you can see it has 0, then we have our payment transaction and there's 10 million microalgos. And I also want to showcase this. Obviously, you can see it in the command line, but it's kind of messy. But if you do AlgoKit Explore, which is a command line from AlgoKit, it will prompt you to open up LoRa. And if we give it a moment, we can see that we have our first block that contains a transaction. And if we have a look at this transaction, we can see that there's a 10 algo payment that happened between the dispenser account to our creator account, which is pretty cool. So we'll keep an eye each time we do a transaction with LoRa. So to get LoRa, in case you missed it, all you have to do is make sure you have your AlgoD, your KMD, and your indexer set to public, and in the terminal, do AlgoKit Explore, and it will prompt you to open it up. Okay, so let's continue on because we still have lots to do. So next, we want to create our Algorand Standard Asset. So what we're going to do is we're going to create sent transaction, that's where we're going to store this transaction. And we're going to have algorand.send.asset_create. Once we open up these parentheses, we'll add what we imported from above, which is the asset create params. Then we'll open up our parentheses and fill in a few fields again. So the first one is our sender, and the sender for creating an asset is essentially the creator of the asset, hence creator.address, since we named it really well. Next, we'll be creating the total amount of these tokens. So the total, we'll just have 1,000. Next, the asset name you can choose to give. So the asset name, let's see. I wonder if Camilo has any suggestions. Maybe we could just do something like Algo Devs.
Or hackathon token, I don't know.
Oh, that's a cool one too. Hackathon token.
Yeah,
awesome.
In this moment, it's important to highlight that we can see with this demo all the things that you can do on Algorand, and something important is without the need of a smart contract. We are interacting using AlgoKit Utils, using AlgoKit that allow us to start our local net, but everything is happening without a smart contract, and that is a super powerful native feature that Algorand offers.
Yeah, it's so cool to be able to create an asset just like this without even touching a smart contract, which is a lot harder to do on other blockchains. So after our asset name, we're going to have our unit name as well. And the unit name is just an abbreviation. So let's just call it, I won't call it hack, I'll just call it talk. Alrighty, and now the final three things, just to make the point of it, but we won't really be using them, but we're going to set the addresses. So with Algorand Standard Assets, you can choose to set a different type of addresses. So the first one is manager, and we're just going to set all these addresses to the creator because we don't have to go that deeply into it. But what the manager address allows is allows for the future to have this asset to be reconfigured or destroyed if it holds all of it. The next one that is possible is the clawback. which basically allows you to take tokens from other accounts if it's set to true. And it can only be set to true when you create the token itself. So if it's never set to true, don't worry. Nobody can just go in and change it. It is very secure. But for example, people may use it if they were afraid of a breach and they want to make sure they can gather back all their tokens. So we'll just set this to creator.address. And then the next really cool thing that you can do as well with Algorand Standard Assets is you can freeze them. And this is more for regulatory, since if there was something happening with the asset and you just wanted to freeze all the asset transfers of that asset, this is where freeze comes in. But once again, it can only be instantiated at the creation. But I just thought it would be meaningful to bring it up. So next, we have to get our asset ID. So we're going to, firstly, I'll add the comment, creating an Algorand Standard extracting the asset ID. So to do this, we're going to store it inside of asset ID. And why we have the sent transaction, this will show you perfectly why we chose to have sent transaction. Because in here, we're going to go to the confirmation. And we're also going to go to the asset index. And this will give us the asset ID we need to be able to do things like opt-in. And we'll also print out our asset ID to have a look at what it looks like. So if we, and I will comment these out as well. If we go to our terminal and we do Python main.py, we should see a 4-digit asset ID. Oh, a little typo. That's okay. I seem to be very bad at the typos today. Let's see. Where is it? Line 41. Perfect. So if we just be careful of the typos and the commas, but if we run that again, we should see a 4-digit asset ID. And if we go back over to LoRa, we will also see we have obviously done some payment transactions, but we have an asset configure here where we created our hackathon token, unit talk, 1,000 of them, and we created it. Pretty cool UI. So now if we go back to our code, we can continue. So next thing we have to do, which we've already done before, so it's quite easy now, is we need to create a receiver account. So we have one account, but we can't do much with just one account. So what you can do is just scroll back up and you can take the code where you already created an account before and you can paste it below, but make sure to change the name. So if we do receiver underscore account, perfect. You can call it whatever you want as well. We can also view that. And if we run that in our terminal as well, we will see, and we also created another token the exact same, but that's okay as this is all just for educational purposes. But we can see our second address. Okay, great. So the next thing we need to do is this address can't do anything unless it has some tokens. So the way we funded our creator account, we just need to fund our receiver account. So you can see it starts to get repetitive, which is good for coding because you don't want things to be super complicated all the time. So if we change the sender's correct, we're getting dispense from the dispenser, but our receiver needs to be our receiver account. And just to make sure I don't do any typos this time, I will copy and paste it. So perfect. So that will essentially fund the receiver account. So the next thing I want to do is, well, we've created our asset and we have our other account. So let's see if we can transfer that asset to the other account. So to do our first asset transfer, let's call it asset transfer. And this is a Algorand.send, as we're sending a transaction to the network, asset underscore transfer. Now, I'm sure some of you have already guessed what's going to happen when we try to do this. And it's going to be our asset transfer params. You already know the show. Open up our parentheses and we have some fields to fill in. So our sender is going to be who has all of the tokens right now, the creator. So the creator.address. Then for our receiver, and this is why we added receiver underscore account, just so it doesn't get confusing, but our receiver account dot address. Next, you will see why we extracted the asset ID. So we're going to send an asset, but how do we know what asset to send? So we set our asset ID equal to, and we named it great again, asset ID, but perhaps you may have multiple assets and you'll want to say asset ID 1 or asset ID 2. Lastly, the amount you are going to send. So we have 1,000, so we'll just send 10. So if we try to run this right now, which we will do, but I'm sure some people are guessing in the comments what's going to happen. But it wouldn't be a live tutorial if it wasn't a mistake that we're meant to do. Just to showcase that if you try to send an asset without the other account opted in, you will receive an error, which you can see down here. And opt-in is basically a feature of Algorand that basically allows, it's like an anti-spam feature. So when you have your wallet, you don't want to be sent a bunch of token junk or things that you're not expecting and you want to have your wallet the way it is. Well, with opt-ins, you choose and you have full ownership of what you want in your wallet, which is pretty cool. So let's opt into the asset and how we're going to do this. So I'm just going to delete this above. And when we're going to do the opt-in, you might have remembered earlier I said we're going to do a group transaction. We're going to do an atomic transfer. So to create a new transaction group, what we do is we have our group underscore transaction, which is equal to Algorand.new underscore group. And by the way, this is a really cool feature that Algorand has, which you would need smart contracts to do in other blockchains. And we're simply going to do it in our first technical workshop, which is really cool. Next, we're going to, so I'll put here, start of group transaction. So we're going to opt in. So to do this, we'll add a transaction into the group transaction called add underscore asset underscore opt underscore in. And we're going to open up our parentheses. Next, we're going to add our asset opt-in params. And we only have 2 fields to fill. So we have our sender, which is the account that wants to be opted in. So we try to transfer to our receiver, and it couldn't happen because the receiver account is not opted in. So let's opt in our receiver.address. And don't forget the .address. I do it a lot. Next, we need to identify what asset we are opted into. So we have our asset ID set to our asset ID. Great. And we want to simulate something cool here. So we're going to have a payment from the receiver. So they're going to pay some algos for some of this hackathon token. So let's add our next transaction into our transaction group. And this one is a payment one. So inside here, we will obviously use our pay params. Then we have a few fields to fill in. We have our sender, which is equal to our receiver account dot address, as the receiver account's going to essentially be paying. And the receiver account is going to be our creator dot address. Lastly, the amount. So the amount will be, let's see, we'll just do 1 million microalgos, which is 1 algo. Great, so we have the opt-in and we have the payment. So now we need to make sure that we have the asset transfer. So same thing again, we have our group transaction and we're going to add the asset underscore asset transfer. When we open up these parentheses, you can guess we'll have our asset transfer params. And we have a few fields to fill in. So we did this before, but just to do it again, we have our sender creator.address, as well as our receiver, which is equal to our receiver account.address. Next, we need to have the asset we want to send, which we've stored inside of our asset ID variable. And lastly, the amount. So for 1 algo, we will send 10 of the hackathon tokens. Now, we're not finished just there. We need to obviously execute this transaction group. So to do this, we take our group transaction and we just .execute. So before we execute this fully, I'm going to write out a few print statements. Just to save time, I'm going to grab them. So here I just have a few print statements. We're going to get the information from the receiver account. We're going to see the receiver account asset balance. So it should be 10, I believe. And then create the remaining balance of the creator address. So if we go into our terminal, and hopefully I have no more typos, but if we do, it's okay. And we do python main.py and cross our fingers. Perfect. So we can see some of our addresses. So let's see, what did we print? We printed our receiver account. So we can see there's 1 algo gone, which is for the payment that we did. And we can also see that we have a total assets opted in 1, which is great. So that means, as you already know, and as we went through in the presentation, with an atomic transfer, either all of the transactions in the group have to succeed or none of them do. So that's a great secure and reliability, which you may need to use inside of your scripts or dApps. But we can see also the receiver account balance is 10. But let's look at it with a way more fancier UI and go to LoRa, because it just looks way nicer. So if we go here, we can see we've been producing a lot of blocks, a lot of transactions, but let's look at some interesting ones. So we see here we have 3 transactions in this block. And if we click over here, we can see that in the transactions, we have 2 asset transfers and 1 payment. If we go into our group ID, we can see that we have our asset transfer. So that is basically an opt-in, as we can see here, of 0. Then we send a payment transaction and we receive the 10 hackathon tokens. So you have done a lot in this live coding tutorial, especially if you have never done any of these before. So what we've done is we've connected to the local net, we've imported a dispenser, we created an account, we funded that account, created an Algorand Standard Asset, created a receiver account, funded that receiver account, and lastly, we made a group transaction where the receiver opts into the asset, sends a payment transaction to the creator, and the creator sends some of the asset that we have created. So now if I continue back to the presentation, we just have a few more slides. and we'll have a big Q&A session at the very end as well. I'll check chat, make sure everything's going okay. Alrighty. Pretty fun. So if we go back, I want to show you a little overview of our robust ecosystem. So if we have a look, we have some payments, wallets, infrastructure, consumer, real-world applications, DeFi. The world is really limitless in blockchain, and I hope that you've seen that, it actually was not very intimidating to build on chain. You've already created assets. You've already done some complex group transactions, so you can definitely go from here. So if we do a little look inside real-world asset tokenization, we mentioned Lofty earlier, TravelX. We obviously have some others like A-Note Music, and a lot more space to be filled in by you guys as well. On the data traceability and tracking side, we have LabTrace, which is a data authentication solution for clinical trials, which really is so fascinating and definitely a need. Whole chain, Lavazza Coffee. If anyone's drinking Lavazza Coffee, shout out to you. They use our chain for supply chain traceability, as well as LW3 and Finboot for the oil and gas industry. In our DeFi protocols, we have Folks Finance, which you can use to lend, borrow, and trade markets. DeFi, by the way, for anyone who is new to Web3, it just means decentralized finance, the same way TradFi is called traditional finance. We have Humble. Humble and Pact actually merged together. They're a decentralized exchange, as well as Tinyman. Next, on the stablecoins, digital money and payments, we looked at Quantos earlier, which has the digital euro backed 1-to-1 by euros. I'll also have USDC coin, HesaPay have theirs, and Immersive, which is really interesting as well. Some big developments are happening. On the more chiller side of things, we have NFTs and games. So we have Exa Marketplace, Dartroom, AlgoX NFT, all NFT marketplaces. Gunny, we have Fractal Monsters. You can try out all these games, but also a cool one I'd like to point out as well, because these are NFTs and games, but NFTs can be used for many things. For example, Book.io as well. But day by day, they use NFTs as insurance policies. On the ecosystem tools and infrastructure side, some of you may already have these wallets already, and if you don't, I really encourage you do, because self-sovereignty is much better. But we have Para, and we also have DeFi or DeFi. We have Daffy, Exodus, a lot of wallets. We also have a block explorer, Allo. So if you're, I don't know, if you used to do Facebook stalking back in the day, maybe you'll like Allo and do blockchain stalking. We also have NFTs. But in the last section of this presentation, before we open it up to Q&A further, I want to show you how, or I want to speak a little bit about how Algorand Foundation supports the ecosystems and how we really want to help. So from the developer tooling that you guys are now experts in, to the ecosystem success side. So, for example, with the last hackathon, we launched an incubator program where many of those hackathon participants went into the incubator program, and they're practicing their pitching skills, they're continuing their networking. A really great opportunity to continue to grow. It doesn't just have to end at the hackathon. The support actually only grows from the hackathon, to be honest. But from ecosystem funding to business development and partnerships, as well as tokenomics and governance. And lastly, with marketing as well. So promoting Algorand technology and its ecosystem of applications with community channels, social medias, content, events, and more. And the main goal is to drive broad awareness and to increase adoption. So I really do hope you enjoyed. Now, we're not finished. This is not the end in speech, but I do hope you enjoyed this session and you'll come join us for session 2. I do want to make a disclaimer that even if you did not make this session, which you may be watching the recording either, but if if you have a friend who didn't make this session, you can jump into session 2 and it's completely fine. Of course, this fundamentals is really important and sound knowledge, but you can still jump into session 2. So make sure you register if you haven't already. I believe if you registered for the first one, you may automatically be registered, but just double check and invite your friends. But in the technical workshop session 2, we'll cover a deeper dive into the powerful capabilities you can leverage with Algorand and get hands-on experience with smart contract development using AlgoKit. I do have one piece of homework for you. It's really not hard, but to download AlgoKit and prepare for the next session, you can simply go to algorand.co/AlgoKit, or there's probably links being sent in the chat as well. But I don't want to just leave it there and say, go download it and look at all that. I do have a pre-prepped video, and I'll also pop into the chat the link to go to AlgoKit. But in this video, I'll walk you through it, but this is a bit about what we'll do tomorrow, but also showing you from, you can download it on Windows, Linux, Mac, but this is a perspective from Mac, how to download it from scratch, like you don't even have Homebrew. So if I go to open screen and we'll just watch this together, we go to Homebrew and you enter it into your IDE. And this is simply going from Homebrew, making sure it's on your path, and making sure it installed correctly. Then going back to the guide, which, a disclaimer, also all of the developer portal is also getting updated as well. So just as a heads up. Next, to download Docker, of course we use CodeSpace today, and CodeSpace is great. You've seen it set up the whole environment for you and to do the AlgoKit local net start. But CodeSpaces you only have them for a month. They're a premium feature. So it is really worthwhile, especially for a hackathon, to have your local environment. So once you download AlgoKit and Docker, and this is going straight from doing it all from scratch, I recommend you just open Docker, but you don't need to do anything else. You just open it and go back to your command line. We do AlgoKit init to initialize a new project. And like I was saying earlier, it's like a form. You choose the name, if you want to do backend, front end, or both. In this small demo, it is just backend. Then you open up your project file, you go into your workspace, and we'll be doing this in the next session, so don't worry. I just wanted to show you that it's a very easy process to set up. And here when we did AlgoKit init, it generates a template smart contract for you. It's just a hello world, but it's quite cool. And then when you build and deploy in VS Code, it will obviously build it and deploy it, which we can see there, it received hello world correctly. But if all of this looks like gobbledygook, don't worry, because we'll get into it, and that's the fun part. But as you can see as well, in Docker, it set it up all of your things. So you simply just needed to open up Docker and go build and deploy your smart contract, and it'll set it all up for you, which I think is pretty cool. But then, let's see. Yeah, perfect. So we'll open up the floor for Q&As, but I just want to say a big thank you. I know you guys took a whole lot of time out of your life to go and do this, so really appreciate it. And I hope you found it very meaningful, and we'll see you for all of the sessions. I recommend going to the entrepreneur one as well, as it's very important. And yeah, feel free to come to our Algorand Discord. I believe Camilo posted it in the chat, and yeah, welcome to Algorand ecosystem and to your journey of becoming an algo dev. So I wonder, Camilo, if we have any questions?
First of all, thank you, Sara. What an incredible session 1. And today we learn about Algorand, the ecosystem, how we can start using AlgoKits to create accounts, send payment with algos, create our own asset, And all this without the need of a smart contract. So this is a pretty powerful feature that Algorand offered to us as a network. And I hope that everyone enjoyed the session 1. And in the session 2, as you mentioned, we are going to do the next step, because sometimes you need to create a smart contract. And that is something that we are going to cover in session 2. So we look forward for all the people that participate into the session to join us in the session 2. And we don't have a lot of questions, to be honest with you. We just have 2 questions. We already answered some of them during your presentation. So I don't know, something else that you want to add before we end today's session, Sarah?
No, it seems good. If anyone does have a question that pops up, or maybe you have an idea for the hackathon that you want to talk about, please come to our Algorand Discord. I believe we have a specific channel. Is it Get Help or Dev Help that you can come and ask questions? Yeah.
Mm-hmm. Yeah. Thanks, Jules, for sharing. I don't know, maybe by mistake I select the wrong email, the wrong link, but in the chat you will find the link to register for the session 2.
Awesome. Yeah. Looking forward to seeing you guys there.
Yeah, for sure. So anything else, Sarah, that you want to share with the people? What could be the next step for them?
Yeah, I guess the next step, to reiterate, is, well, you already done a bunch of coding, so get your local environment set up. There's no point waiting. So go to algorand.co/AlgoKit, and it only takes a few minutes, maximum 10, and that's if you have a Windows, maybe if it's a bit slower. No offense to Windows. But yeah, get your local environment set up. You could even take a step further and try to generate your first smart contract with AlgoKit in it. But apart from that, we're going to cover it all in session 2, Camilo.
Yeah, for sure. And they can still play around with the things that you share with them today, and maybe they can identify the way to use the freeze transaction, the global transaction. There are several things that you can still do that we don't cover in today's session, but that is part of the process.
100%.
Okay. Yeah, so thank you so much for joining us, and looking forward in the next Tuesday session. And if you have any question, feel free to let us know and contact in the Discord. Thank you.
Thank you.